Hello there. I'm so glad we can share this quiet moment together. Outside our window of thought, the night is a vast, calm ocean holding secrets older than memory. Allow the stillness to settle around you like a soft blanket drawn up to your chin. Tonight, we aren't rushing anywhere. We are simply pausing to wonder about the very foundation of existence, the silent, invisible measure that dictates every sunrise and every falling leaf. We often imagine that our universe is defined by this ceaseless tick-tock, a river flowing only forward. But what if that river could disappear? What if the grand tapestry of space held all its moments at once, without a past or a future? Could all the beauty, all the stars, all the quiet truth of it still be real without that steady march? It's a tender question, and we'll explore it with the softness of a whispered thought, letting the complex ideas settle lightly in your mind. If this gentle journey into the deep structures of the world brings you a moment of peace, a quiet like, and a soft, subscribe, help others find their way to this calm, one sleepy soul at a time. The answers can wait. For now, let your mind drift free of the clock. We'll begin together, unhurried and warm. What time is it where you are right now? Not on some perfect clock in an observatory, just on the little screen near your hand, or the quiet numbers glowing somewhere in the room. Maybe it's late and the world outside your window has gone soft and dim. Maybe a few lights are still scattered across distant buildings, like small stars that haven't decided to sleep yet. Or maybe it's earlier for you, a slow evening where the day hasn't quite let go, or a pale morning where the world is just beginning to stir. You don't have to say it out loud. Just notice it for a moment. Notice the number, the hour, the small arrangement of digits that tell you where you are in the story of your day. And then notice how quickly that moment slips away. You look once, and it's here. You look again, and it's already different. Time is always doing that, appearing just long enough to be named, then sliding out of reach before you can hold it still. You mark a special hour, a birthday, a midnight on the edge of a new year, and almost as soon as you name it, it belongs to the past. Even an ordinary second doesn't stay. It arrives, brushes past you, and then it lives only as a memory or a number written somewhere. Time visits, but it doesn't stay. So tonight, instead of chasing it, we're going to let it slow down together. Not because we can stop it, no watch has ever done that, but because we can step a little to the side of it, just enough to look at it gently without trying to control it. If this kind of quiet wandering feels good to you, if you like resting while the universe unfolds like a soft, patient story, you're welcome to leave a gentle like, maybe even subscribe. It helps others stumble into this calm too, one sleepy listener at a time. For a moment, let all the clocks in your life fall a little quieter. Every alarm, every deadline, every "I should have done more by now." Just imagine something very simple. No ticking hands, no calendar squares, no before and no after. Just a universe without time. At first, that sounds like pulling the floor out from under reality. How can anything happen if there is no when for it to happen in? How can a star be born? How can you grow up or grow old if there is no line to move along? It feels like saying that music exists without notes, or that a book exists without pages. But what if reality doesn't need the floor we think it stands on? What if we are the ones who insist on laying down a track because walking on trackless ground feels too strange? To feel our way into this, it helps to start somewhere familiar, the way you experience time right now. When you wake up, your day has a shape. Morning has a certain light and a certain feeling. It leans toward afternoon, and afternoon leans toward evening. You move along that path as if you're on rails, carried from one moment to the next in a single direction. Yesterday is behind you, tomorrow is ahead, and today is a narrow bridge you're always crossing. It's so natural that it rarely occurs to you that this might not be the way the universe itself keeps track of things. But physics, especially the physics that tries to describe the deepest rules of reality, has a different way of looking. In many of the equations that describe how gravity bends space or how particles shift and interact, time does not appear the way we use it in conversation. The math doesn't always say, first this, then that. It often says something more subtle. These things are related. If this is true, then so is that. Imagine someone drawing a diagram of a dance. They might not write step 1, step 2, step 3. Instead, they draw lines showing how partners move around each other, how one turn echoes another. The order is there, hidden, but the diagram itself cares more about relationships than about a ticking sequence. In a similar way, the deepest laws seem to describe how reality fits together, not how it marches forward second by second. When we talk about time in everyday life, we treat it as a kind of cosmic ruler that exists independently of everything, ticking away in the background, the same for everyone, everywhere. But those quiet equations don't need that ruler. They only need the structure of how things influence one another. Time, as we live it, might be something we add afterward, our mind's way of stitching those relationships into a story we can follow. If that feels unsettling, you're not alone. Even Einstein had to unlearn his own instinct about time to see the universe more clearly. He grew up with the same sense of now that you have, the same feeling that there is one great universal clock sweeping everyone along together. And yet, while he sat with his thoughts, he dared to imagine something stranger, that time could stretch and bend. He came to understand that time is not absolute. It depends on where you are, how quickly you're moving, and how strong gravity is around you. Two people can live through different amounts of time and still meet again and share a smile in the same moment. That means the universe doesn't hand out time in identical portions to everyone. It doesn't say, here is 1 hour, the same for you and for me and for the distant star. Instead, time wraps itself around each path, each vantage point. It's not universal, it is personal. Your time and someone else's time can diverge like two trails in a forest, both real, both valid, both leading to the same clearing in different ways. And if time is personal like that, if it depends on motion and gravity and perspective, maybe it isn't as fundamental as we once believed. Maybe it's not the bedrock, but a pattern that appears when certain conditions are met. One way to think of it is that time is how the universe keeps track of change when seen from the limited point of view of a being like you, with a brain that needs events to line up one after another. If that's true, then somewhere beneath that personal flow, there might be a deeper reality where time, as you know it, isn't needed at all. Try to picture, just for a moment, a universe that simply is all at once, not flowing, not moving, not ticking, just existing. Every event that has ever happened and every event that ever will, all laid out together like a vast, intricate landscape. In this picture, you don't travel through time any more than you travel through the existence of a mountain by standing in front of it. You are simply in one part of the landscape now, and later you will stand in another part, but the landscape itself does not change because of your journey. Maybe in one valley of that landscape, a child is taking their first steps. Somewhere else, someone older is sitting by a window, watching rain. In another region, a star is just beginning to shine. Not far away, another star is breathing out its last light. All of those moments coexist in the great pattern. You, where you are now, occupy a narrow slice, a single hill with a single view. As you move through time, you are really moving from one vantage point to another, surveying different parts of a picture that has always been complete. This is hard to hold in the mind, and that's okay. Every instinct you have has been shaped by clocks and calendars, by school bells and appointments, by the way days and nights follow each other in order. You live in time the way fish live in water. You move through it, assume it, without noticing it until you try to imagine being outside of it. When you try, your thoughts may slip away, like trying to hold fog in your hands. You don't need to force the image to stay. Just touch it briefly, then let it drift. Even if it feels slippery, it's still worth lingering near this idea because it changes how you think about your own now. In this view, time as you experience it, past, present, future, is something that appears because you are not seeing the whole picture at once. It is the story your mind tells itself as it walks through the landscape step by step. Like someone standing very close to a painting, you see brushstrokes and you feel motion. Step back far enough and the sense of motion dissolves. The whole image is there, calm and complete. If this is the case, then maybe the question isn't, can the universe exist without time? Maybe the softer question is, does time exist only because of the way we look at the universe? If we could somehow step back far enough, not physically, but in understanding, if we could see the whole cosmic painting in one unbroken view, would we find that time as we know it has been an illusion all along? Not fake or useless, but like a helpful line on a map. That doesn't mean your watch is lying to you. The hours it shows you are still meaningful. They help you decide when to meet a friend, when to rest, when to turn off the lights. Time still runs your day, but it might not run the universe in the way we once imagined. It might be the way your mind turned something too vast, too all at once, into something you can live inside without being overwhelmed. There is a quiet comfort in that thought. If the universe doesn't need time in the deepest sense, then perhaps nothing is ever truly lost. Every moment could simply exist forever in that great landscape, like pages in a book that never closes. The page you are on feels like now, but all the other pages are still there, each with its own scenes, its own small miracles. And still, in your daily life, time feels close and personal. You've probably had evenings where you sit somewhere quiet and at some point realize you have stopped paying attention to the clock. Minutes, maybe whole hours, slide past like water, and you don't notice until something nudges you back. For that little while, time didn't matter. You weren't counting it or measuring it. You were just there, suspended in a gentle now that didn't need to be carved into pieces. You felt the opposite, too, waiting in a line that barely moves, sitting in a room you don't want to be in, watching numbers change on a screen. Each second feels swollen, stretched thin, as if it might snap. 10 minutes can feel like an hour when you'd rather be anywhere else. Objectively, the clock keeps its steady pace, but your experience of it doesn't. It speeds up, slows down, curls around your feelings. That alone is a clue that the time you live in, the one that shapes your memories and your sense of self, is not as rigid as it appears. And in the deepest laws of the universe, time is slippery in a similar way. It does not tick in perfect unison everywhere. It bends and shifts depending on speed, gravity, and perspective. Einstein showed us that if you could ride in a spaceship traveling close to the speed of light, your clock would run more slowly compared to the clocks of the people you left behind. To you, inside the ship, everything would feel normal, but when you came back, you would find that more time had passed for those who stayed than for you. Time is not a single drum beating the same rhythm everywhere. It is more like a web of many paths, each with its own tempo, each shaped by where it moves and what surrounds it. Somewhere between your private sense of "that went by so quickly" and the equations that describe bending space-time, there is a shared truth. Time is not the stiff, straight line we once thought it was. It is flexible, responsive, personal. And as you lie wherever you are, listening to these words drift by, you are already feeling that softness in your own way, the way 1 hour can hold so many different kinds of forever, depending on how you spend it and who you spend it with. If you could take that idea and push it to its limit, step off your familiar path and ride a near light-speed spaceship, then come home, you would see that softness turned almost into a tear. Only a few years would have passed for you, while decades might have slipped by back on Earth. Friends would be older, streets a little changed, the world slightly out of step with the memory you carried away. Your own clock would say it was right, and so would the clocks on the ground. Both stories would be true, and yet they would disagree. Time, it seems, is flexible enough to stretch depending on the path you take. You don't need a starship to feel a faint echo of that strangeness. You've already brushed against it in quieter ways, in those moments when you stopped paying attention to time at all. Time didn't stop. Of course, the earth kept turning. Your heart kept beating, but your experience of it shifted. Minutes blurred into each other or thinned and lengthened, simply because your mind was no longer measuring them in its usual, careful way. That tiny softness in your sense of now is a clue. If time can feel different depending on how you look at it, maybe it isn't as fundamental as we once believed. Maybe it isn't a rigid backbone of reality, but something that grows out of the way. A mind like yours notices change and stitches it into a story. Instead of being a cold, external thing that exists on its own, time might be a pattern, our way of keeping track of how the universe rearranges itself. Imagine, just for a moment, that you could step completely outside the habit of measuring time. No clocks on the wall, no notifications, no calendar quietly counting weeks and months. Not even the thought that something came before this, or that something will come after. You would still be here. The room around you would still exist. Somewhere above, the stars would still burn. They wouldn't vanish just because you stopped counting seconds. The universe doesn't check a wristwatch to know how to keep going. It is. You can taste a little of that outside of time feeling without going anywhere at all. Close your eyes for a while, not to sleep, just to soften the edges of what you're paying attention to. Let sounds come and go without naming them. Don't try to count. After a little while, your sense of how long begins to fray. You think only a few minutes have passed when it's been 20, or you feel as if you've been lying there forever when only 10 minutes have slipped through. Your brain needs markers to know that time has passed. Events, changes, the feeling of something beginning and ending. When those markers fade, your grip on time fades with them. Without motion, Without difference, time slips out of focus, and in physics, that simple observation is echoed in a deeper way. Many scientists think that time itself may be nothing more than a way to track change. If absolutely nothing changed anywhere in the universe, if every particle stayed exactly where it was, every star frozen mid-glow, every atom perfectly still, there would be no way to tell that time was passing. There would be no heartbeat to count, no planet to watch revolve, no shadow sliding across the floor. Time and change might not be separate at all, but two ways of looking at the same thing. Take away change, and time might quietly vanish with it, not in a dramatic stop, but in a gentle fading, like chalk washed from a sidewalk by rain. If time is just how we keep track of change, then maybe time doesn't actually flow on its own. Maybe it is your mind that flows, moving from one state to another, stitching together a sense of motion through a universe that is already laid out in its entirety. Some physicists use a picture for this, the block universe. In that picture, the past, present, and future are all equally real, all coexisting in a single vast structure. Another way to imagine it is as a book whose pages are already written from the first to the last. All the chapters exist at once, resting quietly together. The page you're reading feels like now. The earlier pages feel like before, and the unread ones feel like later. But the book itself doesn't move from cover to cover or grow new pages at the front. It simply is. When you flip through it, your perspective changes. You move. The story on the page does not. In the block universe, your life is like that book. You are a reader moving through already written pages, one after another, weaving the feeling of a flowing time. When you stop thinking so hard about the clock, you almost get a tiny glimpse of that picture. The pages stop cracking so sharply apart. Moments begin to blur together like colors in a watercolor painting, still distinct but softly merging. It's not that time disappears, it's that your awareness loosens its grip on it. In that loosening, you may be coming a little closer to how the universe actually carries on, not as a line being drawn in real time, but as a pattern that already exists, waiting to be traced. There is a quiet comfort in that thought. You don't have to control time. You don't have to race it, chase it, or hold it still. You are not failing when you feel it slipping away, because it was never really yours to hold. When you stop trying to pin it down, time softens, and you can almost sense something beneath it, an underlying reality that isn't rushing anywhere. That deeper layer doesn't care whether you're counting seconds or years. It's there whether you mark it or not. That might be the first step toward understanding how a universe could exist without time. You don't have to imagine everything suddenly stopping, planets frozen and people holding their breath forever. Instead, imagine that time was never the engine running the show to begin with. Maybe it's more like a shadow cast by something else, something deeper and more fundamental. Wherever there is change, the shadow appears, and you call it time. Where there is no change, the shadow disappears, and the word time simply doesn't apply. The next time you glance at a clock on your wall, on your phone, on the dashboard of a car, remember that it isn't telling you what time is. It's telling you what time looks like to a creature who has to move through the world one moment at a time. The numbers, the ticking hands, the shifting digital display, they're all ways of translating the changing universe into something you can organize your life around. If you could somehow step back far enough from that picture, the clock might not be needed at all. The universe would still do whatever it does. Stars would still ignite, and galaxies would still collide. People would still be born and die, laugh and cry, make choices and leave traces. All of that could be part of the great structure, written into the universe itself, without a single second ever flowing from one place to another. Once you start to see things this way, even just in the corner of your mind, you can begin to ask softer, deeper questions. If time isn't as real as it feels, then what is it exactly? If the universe doesn't actually run on time the way a train runs on tracks, what does it run on? What is the more fundamental thing that gives rise to this sense of before and after? You may have stared at a clock long enough at some point in your life to feel how convincing it can be. The steady tick, the clean sweep of the second hand, the orderly march of numbers changing from one to the next. It feels unshakable. But that feeling is a trick of perspective. The clock doesn't reveal time itself. It only measures change in a way we've all agreed to call time. Think about what a clock actually does. It doesn't reach out into the fabric of the universe and grab hold of a cosmic strand named time. It just moves. A pendulum swings. A crystal vibrates. Gears turn. Tiny electric pulses fire in circuits. Your phone's screen updates. Because those changes are regular and predictable, we use them as a reference and build our schedules, our histories, our habits around them. That doesn't prove that time is a fundamental ingredient of reality. It only proves that we've become very good at counting motion. Motion is not the same thing as time. You can take the spin of a planet around its star, the vibration of an atom in a quiet lab, the back and forth swing of a pendulum in an old clock tower, and you can build a system that counts those changes. Each repetition becomes a second or an hour because we say so. But if, in some unimaginable stillness, nothing moved at all, no planets circling, no hands ticking, no atoms trembling, what would be left of time? Would there still be something flowing underneath that silence? Or would the idea of time simply evaporate, not because it was destroyed, but because it was never an independent thing to begin with? That's the unsettling question physicists have been wrestling with for more than a century. We have built our lives around clocks, drawn our days and nights around their circles, but when we look out into the universe with our best theories, there is no sign of a master clock ticking behind the scenes. Nowhere in the laws of physics is there a hidden metronome, a universal heartbeat, insisting that everything must step in rhythm. Einstein's equations don't describe a river of time flowing past you. They describe relationships between mass and space, between energy and motion. They tell you how gravity curves the paths that things take, how light bends, how matter moves. Time only appears when we step inside the picture and decide to slice those relationships into a sequence that makes sense from our limited vantage point. We choose a way to say first and later, and the math allows it, but it doesn't insist on it. If that still feels abstract, there's a gentler way to see it. Imagine watching a movie, one frame at a time. Each frame on the film strip, or each still image on a digital timeline, is completely frozen. Nothing moves inside a single frame. A hand is half raised. A leaf is halfway through its fall. A mouth is caught between words. On its own, each picture is timeless. When you play them in order, one after another, your mind turns those still frames into motion. You see someone running, laughing, reaching out. You see a story unfold, even though every single frame already existed before you pressed play. The movement was not created as the film advanced. It was created in your perception by the way your brain connects one frame to the next. In this view, Time is the same kind of gentle illusion. Every frame of the universe, the past, the present, the future, may already exist in that vast block we talked about. Your mind is simply watching them in sequence, stitching them into a flowing narrative, and calling that flow time. The story feels real. The feelings inside it are real. But the river you think you're floating on might be, in the deepest sense, just a path you are tracing through something that was always there, waiting for you to notice it, one quiet moment at a time. And once you see it that way, the role of clocks starts to look a little different too. Clocks are a little like projectors in a dark, quiet room. They don't create the film. They don't write the scenes. They only feed the frames through at a steady pace, one after another, giving your eyes and your mind something to follow. We watch their motion and take it as proof that time itself must be real and solid, flowing like the beam of light from the projector. But all the clock is really doing is offering us a rhythm, a gentle metronome for the changes that are already there, helping our wandering minds keep pace with a story that may, in truth, already be complete. If that rhythm vanished, if every clock on Earth silently stopped, the gears of the universe would not grind to a halt. Planets would still orbit, stars would still burn, and the deep structure of everything would remain exactly as it is. The only thing that would change is your sense of moving through it. Without numbers sliding forward, without ticking hands, you would lose some of the feeling of being carried from one moment into the next. Einstein himself hinted at this in a quiet, personal way. When his close friend Michel Besso died, he wrote to the family that for us convinced physicists, the distinction between past, present, and future is only a stubbornly persistent illusion. He wasn't just being poetic. He meant that the mathematics he trusted didn't give any special importance to our idea of now. From the universe's point of view, as far as relativity can tell us, there is no single grand clock striking the same shared instant for everyone. What counts as now for you might already be later for someone moving very quickly, or for someone sitting deep in a strong gravitational field. Time is local. It clings to your path, your speed, your surroundings. It is flexible, personal, tied to where you are and how you move. And if it is personal in that way, maybe it is not the backbone of reality we once believed. Maybe it is more like a story each observer tells about the same underlying structure. But if clocks are not measuring something fundamental, why does time feel so inescapable, like the one thing you can never step outside? Part of the answer lies in the way your brain is wired. Memory links one moment to another in a continuous chain. You don't remember the future. You don't feel the past in your skin. You live inside a narrow window of experience, a moving bubble where awareness touches only a thin slice of the whole. That window creates the strong illusion that you are being carried forward, that something behind you is fading, and something ahead is waiting to be reached. The ticking clock reinforces that illusion. Every second that passes on its face is like a small tap on your attention, reminding you that there is a direction to this movement, a before and an after. You've probably felt this loose in its grip. Maybe you were so absorbed in a conversation or a book that you looked up and realized the sky had changed color and hours had quietly gone by. Nothing magical happened to the clock. It didn't race ahead. You simply stopped measuring. For a brief stretch, you stepped partly out of the illusion. In quantum mechanics, the framework that describes particles and fields in their tiniest behavior, time often appears only as a kind of bookkeeping tool. There are ways of writing the equations that govern quantum states, where you don't see time sitting there as a central character at all. Instead, those equations describe how one possible configuration of a system relates to another. They talk about relationships and possibilities. If the system looks like this in one description, what other descriptions are consistent with it? Time, in that view, is something we create when we step back and compare one configuration with another. When we say, this one came before that one, or this one came after, without someone marking before and after, the math does not automatically need time. You wake up to alarms. You plan your days by the hour. You celebrate birthdays. You watch the hands move and feel as if you are moving with them, as though the clock were pulling you along. Yet, from the universe's more indifferent perspective, there may be no movement in the sense you usually mean. Every tick of the clock might just be another step you take through a landscape that is already there, full and complete, waiting to be walked. If that is even partly true, it leads to a stranger question. If time is an illusion, subtle, but still an illusion, why does it seem to have rules? Why does it only move forward for us? Why can you remember the past but not the future? Why does a broken glass stay broken on the floor and never, in all your days, leap back up onto the counter and knit itself together? For most of human history, time seemed beautifully simple. The sun rose, the sun set, and that rhythm felt universal and absolute. A day where you stood was a day everywhere, and time seemed like the one background you could trust not to change. At least, that was the assumption, until a quiet clerk in a Swiss patent office began to see it differently. Einstein didn't set out to dismantle time. He was trying to solve a modest puzzle about how light behaves. Physicists of his era believed that space and time were separate. Space was the where of events. Time was the when. Like a stage and a backstage clock, they seemed distinct. But when Einstein looked carefully at how light moved, he noticed something that refused to fit the old framework. No matter how fast you ran toward a beam of light, or how quickly you tried to flee from it, light always reached you at the same speed. It never sped up to meet you sooner, or slowed down to let you catch your breath. That one stubborn fact changed everything. If the speed of light truly never changes, then something else has to. And what Einstein found was that what gives way is time itself, along with distances in space. Imagine two people standing apart. One stands still, the other moves quickly past. Each carries a small clock. Your first guess would be that those clocks tick in perfect sync, second for second. But Einstein's equations said otherwise. For the person in motion, the clock would run slower compared to the clock of the one at rest. Not broken, not miscalibrated, just slower from the other person's point of view. And it would not just be the clock. Their heartbeat, their aging, their whole personal flow of time would be stretched out relative to the one who stayed still. It meant there is no single, universal now shared by everyone in the cosmos. Time is not a river carrying all boats forward at the same speed. It is more like a flexible fabric, stretching or bunching, depending on how you move through it and what masses lie nearby. Two people can live side by side and yet experience different flows of time, and neither is wrong. Each is simply following their own path through space-time. Einstein's insight went further. He realized that space and time are not separate realms at all. They are two aspects of one unified thing, space-time. You cannot tug on one without tugging on the other. A massive planet or star presses into that fabric like a heavy ball, resting on a soft sheet, creating curves and hollows. Everything nearby follows those curves, not because some invisible force is yanking on it, but because the geometry itself is telling it how to move. Even time bends around those curves. A clock sitting on Earth ticks slightly slower than a clock far out in empty space, away from strong gravity. Nothing is wrong with either clock. Gravity has simply changed the flow of time itself. In a stronger gravitational field, that slowing becomes more dramatic. Near the edge of a black hole, time for a person hovering close by would crawl compared to the time passing for someone far away. You've been living inside this effect your entire life, even if you've never felt it. Your feet are a little closer to Earth's mass than your head. That means, by an unimaginably tiny amount, time at your feet is running slower than time at your head. The difference is far too small to notice, but it is real. Sensitive instruments can measure it. The universe is constantly tailoring the flow of time differently at different heights, different speeds, different places. What Einstein uncovered is that time is not a fixed backdrop, not a rigid, universal grid on which events are pinned. It is part of the stage itself, woven together with space. And the stage can be stretched, tilted, and curved. The ticking of your clock, the rhythm you live by, is not a fundamental cosmic drumbeat. It is a local rhythm, a pattern specific to where you are and how you are moving. If time can change, then it is not the absolute, universal thing we once thought. It is a feature of how the universe arranges itself, something arising from the geometry of space-time. And if it is only a feature, then perhaps it is not truly fundamental at all. Einstein's equations also don't actually need time to flow in the way you picture it. They do not describe a universe being updated moment by moment, like a screen refreshing. Instead, they describe a structure that simply exists. Past, present, and future are all contained in that structure, as if on a map. You don't need a clock to describe the entire map. You only need a clock if you are walking across it, one step at a time, experiencing it from within. This is why many physicists now suspect that time, at least the time you feel passing, might be a secondary effect. From a higher, more abstract view, the universe could be timeless, a complete whole in which what you call yesterday, today, and tomorrow all coexist. Your mind just follows a single path through this whole, and that motion of awareness creates the sensation of time flowing forward. Yet the feeling of time is hard to shake. It seems to have a direction, an arrow, always pointing from past to future. If you've stood by a river and watched it flow, you know how natural it is to think it has to go that way. It has no choice. But in the careful language of physics, that river does not always flow at the same speed. Sometimes, in the quiet depths of the universe, it slows almost to a stop. This isn't just a metaphor. It is one of the best tested effects in science. Time really does not tick the same way everywhere. If you carry a clock to the top of a mountain and leave another at sea level, the one at the summit will run slightly faster. Your life will not suddenly rush ahead if you live at high altitude, but the clock's record will quietly show that a little more time has passed for you than for someone who stayed closer to the ground. All of it points back to the same gentle, unsettling truth. The ticking of your clock is not the voice of the universe. It is the sound of your particular path through space-time, the rhythm your corner of reality happens to keep, while the larger, timeless structure holds steady beneath it all. And if you want proof that this isn't just a poetic way of speaking, you can bring those clocks back together and listen closely. If you compare them carefully enough, the difference isn't just in your imagination. It shows up in the digits, in the tiny mismatch of their ticks. Time itself has been moving at two slightly different speeds. One clock has lived through a little more of it, the other through a little less. And if you push that effect far enough, it stops being tiny and becomes impossible to ignore. Imagine yourself hovering close to a black hole, out there in the silent dark. From far away, someone watching you would see your motions slow and stretch. The way you raise a hand, the way you turn your head, all of it would be drawn out, as if the universe were watching you through thick glass. Your voice, if they could hear it, would be pulled into a long, low sigh. Your clock would crawl, almost stopping altogether from their point of view. Inside your own little bubble of experience, though, everything would feel perfectly normal. You would see your hands move at their usual pace. You would feel your own breath rising and falling, your own thoughts passing through as easily as ever. Minutes would feel like minutes to you. But in the wider universe, ages could pass in what felt to you like a short conversation, a brief pause, a moment of stillness. This stretching of time is what we call time dilation. It isn't a trick of perception or a weakness in your mind. It's built into the structure of reality itself. Einstein's equations didn't just hint at it, they predicted it clearly, and experiments have gone out into the world and found it, over and over again. Astronauts aboard the International Space Station orbit Earth at high speed, wrapped in a slightly weaker gravitational field than those of us on the ground. When they come home, their bodies are almost untouched, but their clocks, and in a very literal sense, their cells have aged just a tiny fraction of a second less than the people who stayed on the surface. The difference is small, but it's real. The technology that quietly guides you through your day depends on this. GPS satellites fly high above Earth, moving fast, far from the full pull of gravity. Their onboard clocks tick at a slightly different rate than clocks on the ground. Engineers have to correct for time dilation. Adjusting the satellite's timing or the positions they send to your phone would drift, and your maps would slowly fall out of step with the real world. Even the calm blue dot on your screen that tells you where you are carries hidden inside its calculations an admission that time is not absolute. If time can stretch like this, speeding up here, slowing down there, then it isn't the constant, rigid background we once imagined. It's more like a property of the universe that bends and adapts, a quality woven into the fabric of space itself. And when you let that idea sink in, something quietly strange begins to happen. You start to realize that the universe doesn't experience time the way you do. It doesn't hold a single shared clock that all things obey. Instead, it holds countless local rhythms, each one tied to speed and gravity, each one its own small river of moments. Stand close to a black hole, and your river slows to a trickle. Drift out into empty space, where gravity is gentle, and your river runs a little faster. Curl up in your bed on Earth, and you follow the pace of this planet's pull. The universe contains all of these rivers at once, each flowing at its own pace, and yet they coexist without argument. There is no contradiction in this quiet flexibility. No cosmic voice steps in to say, "This clock is right, and that one is wrong. They are all right for the places they inhabit. And that flexibility carries a kind of calmness. If time can run at different speeds, then your personal now is just one of many ways the universe measures itself. It isn't the universal present, some grand central moment. It's just yours. Someone else, in another place, moving differently or feeling a different strength of gravity, is living through a completely different stretch of time. Their seconds are not the same as yours, and yet both of you are correct, faithfully following the contours of space-time where you are. There is something almost peaceful about that. You are not racing against a single, unforgiving clock that applies to everyone, everywhere. You are moving through your own local rhythm. Even that rhythm isn't fixed. It can be stretched, slowed, altered by the shape and weight of space around you. In the deepest, most extreme parts of the cosmos, time practically comes to a halt. Near the edge of a black hole's event horizon, a second for you could last longer than whole ages of the outside universe. Your watch would tick on as usual, but everything beyond would seem to race and fade, galaxies aging while you linger at the edge. If that's possible, then the picture of time as an unstoppable, uniform river begins to shimmer. Maybe it isn't one river at all. Maybe it's a network of streams, each one winding through valleys of gravity and hills of motion, bending and narrowing and widening depending on where it flows. Some streams rush, some stroll, some nearly still themselves into a pool. And if that's true, then it becomes easier to imagine a reality where those streams disappear altogether, where the riverbed is dry but the landscape remains. The rocks, the mountains, the contours are all still there. The water was just one way of passing through them. This is where things begin to connect with deeper ideas. If time can slow almost to nothing near a black hole, if it can run at different speeds depending on where and how you exist, then it's natural to wonder whether there are places or conditions where it doesn't exist at all. Some physicists believe that this is exactly what happens at the deepest level of reality. In that view, time is not a basic ingredient. It emerges only in certain situations, the way temperature emerges when you talk about many particles together. A single atom doesn't have a temperature on its own. It just has energy. Temperature only begins to make sense when countless atoms jostle and move in concert. It is a property of the collective. In the same way, for the universe, at its most fundamental level, maybe time doesn't exist either. Maybe the notion of before and after only appears when you zoom out and look at many events together, when you talk about large systems, big patterns, long stretches. On the tiny foundational scale, the equations might have no need for time at all. Before wandering all the way down there, it's worth pausing to feel what this means for how you see your own life. Every time you glance at a clock, you're glimpsing just one version of time's flow, the one that belongs to your particular path and place. Every time you wait for a message, a result, a morning to arrive, you're leaning on a sense of time that is only local, only yours. Beyond that familiar circle, in the larger universe, the river bends in ways you cannot feel. It speeds up in some places, slows in others, and in some regions, like near black holes, it nearly stops. If time can pause, even in that hidden, quiet way, then it's not a big leap to ask, what if, in some deeper sense, it could vanish completely? If you think of your life as a string of moments, it feels natural to imagine each one being born and then disappearing as the next arrives. You wake up, and that waking moment comes into being and then is gone. You laugh, and the laughter seems to fade into nothing as the day moves on. It's like a row of candles being lit and then blown out, one by one. But what if that's not how it works at all? What if none of those moments actually go anywhere? What if every single one of them simply exists, fixed and unchanging, always there, whether you are paying attention or not? This is one of the strangest ideas to come out of modern physics, but it's taken seriously. In some of the deepest theories of the universe, there are no equations that say this moment becomes the next one. The math does not speak in terms of flow or motion. Instead, it describes structures, relationships between events, patterns that simply are. In that picture, what you call now is just one location in a vast landscape of moments. The past isn't destroyed or erased. The future isn't a blank space waiting to be written. They all exist at once, side by side, woven into a single timeless reality. It's not an easy thought to rest with, because it runs against everything your senses tell you. You wake up, you eat breakfast, you go about your day, you watch the light outside shift from morning to afternoon to dusk. It feels like movement, because that's how your mind organizes experience. But that movement might not belong to the universe. It might belong only to you, the observer walking through a static structure, like a reader moving through a story one page at a time without realizing that the entire book is already sitting there, complete. Physicists sometimes return to the same name for this picture, the block universe. Imagine all of time laid out like a map on a table. Every point on that map, every event, every moment, every small decision and distant explosion already exists. You don't see the whole map because your consciousness can only occupy one location at a time. You stand in one tiny region and call it now. The rest of the map is no less real. You just haven't walked across it. This view comes straight from the logic of Einstein's theory of relativity. In his equations, there is no hidden master clock ticking behind the scenes. There are only relationships between events in space-time, intervals, angles, curves. Your now is different from someone else's now, and there's no cosmic referee with a whistle declaring which one is the true present. That means the universe doesn't privilege this instant over any other. All moments exist equally in the structure, even the ones you think of as long gone or yet to arrive. The first light of the early universe, the last faint glow of distant future stars, the quiet moment you're in right now, they all sit on the same map. If this feels unsettling, it's understandable. It seems to blur or even erase the difference between past, present, and future. But it also gently solves a puzzle that's hard to answer otherwise. If time were truly flowing, like water in a river, where would it be flowing from, and where would it be flowing to? If the future doesn't exist yet, how could you ever arrive at it? If the past no longer exists, why can you remember it in such detail? Feel it in your bones. Dream about it at night. The block universe sidesteps all of this. Nothing flows, nothing vanishes, nothing begins or ends in the way we imagine. The structure simply is. Your sense of movement is the path your awareness traces through it. That leads to another soft question. If every moment exists, why don't you experience them all at once? Why are you not overwhelmed by an avalanche of past and future pressing in on you from every direction? The answer may lie in how your mind works. Your brain stitches together a sequence of events into a coherent story. It needs that story to function. Without it, you'd be lost in a fog of disconnected impressions. So instead of showing you the entire structure at once, your mind offers you a single slice, then another and another. That slice feels like the present. The stitching between slices feels like time. In that sense, time becomes less like a river and more like a spotlight, slowly sliding across a stage that was already built before the show began. Wherever the light falls, you say, "This is happening now." The rest of the stage, hidden in shadow, is no less real. It's simply not illuminated for you yet. There are even hints from quantum mechanics that support this notion of a hidden timelessness. At very small scales, particles don't seem to have definite positions or paths until we interact with them, until some measurement is made. Between those interactions, the math we use to describe them doesn't always contain time in the way we expect. It talks instead about possible states and how they are related. The universe, at its most fundamental level, may not be ticking like a clock. It might simply exist as a network of possibilities, all connected, with time appearing only when you zoom out far enough, only when a mind like yours reads the pattern and insists on a before and an after. If that's true, even just as a possibility, then every moment might be permanent in its own gentle way. When you laughed at a joke years ago, when you took a first step as a child, when you looked up at the stars for the very first time and felt something quiet and huge inside you, those moments might not have fallen away into nothing. They might still be there, fixed in the structure. You have moved on, but they haven't. In this way of seeing things, time doesn't become meaningless. It changes shape. Instead of being a force that drags you forward, it becomes a way of navigating a landscape that's already there. The past doesn't really disappear. The future isn't waiting in an empty way. You are walking from one fixed moment to the next, tracing a line through a timeless whole. And if that's the case, it raises an even more intriguing question. If the feeling of time is an illusion created by moving through these unmoving moments, what would it mean to step outside that motion entirely? What would it look like to see the whole structure at once, not just this moment, but every moment, all together? When you picture the universe expanding, it's natural to imagine galaxies rushing through space as if they were running across a stage, bracing away from each other through some pre-existing emptiness. But that isn't what our best theories say is happening. The galaxies are mostly adrift, almost still in their local patches of sky. It's space itself that is stretching. The galaxies you see in deep sky images are not flying apart because they're racing through some giant, empty container, like marbles flung across a floor. The container itself is changing. The space between them is growing. Distances widen, not because things are traveling through a pre-existing stage, but because the very fabric of reality is quietly unfolding beneath them, adding more room between every point. If that picture feels a little strange, you're not alone. It's already a lot to take in. Space, something you can't touch or hold, stretches. Galaxies that might think of themselves as sitting still in their own neighborhoods find that, from our point of view, they drift away as more and more space appears in between. Once you let that idea settle, it gently nudges you toward an even deeper question. If space can stretch, can time ever be left behind? We tend to tie the two together so tightly in our minds that separating them feels almost impossible. Distance and duration. Where and when your thoughts wrap them into one bundle so naturally that you hardly notice you're doing it. Einstein's work reinforced that feeling and transformed it at the same time. He tied space and time together into a single entity, space-time, where changes in one are entangled with changes in the other. When mass bends space-time, it bends both space and time at once. When you move faster through space, you move slower through time. The two are woven together, like threads in one fabric, inseparable in the way we usually imagine the world. And yet, the universe seems to play by rules that don't always match our first intuition. Space can expand. We have watched the evidence accumulate. Distant galaxies appear to drift farther and farther from us. Not because they're firing rockets and throwing themselves outward, but because there is simply more space between us than there used to be. This expansion doesn't seem to require anything visible to happen to time itself, at least not in the way you feel it moment to moment. You don't wake up one morning to find your seconds have grown longer just because a galaxy billions of light years away is receding faster than you can comfortably imagine. Your heartbeat doesn't slow in sympathy with cosmic distances. Your watch doesn't suddenly skip ticks. That quiet mismatch suggests something subtle but powerful. Space and time are tied together, yes, but not always in the way we casually think. Space can evolve, grow, change in size, while time is something you experience locally, right in the middle of it all, as if you're standing still while the cosmic fabric stretches around you in directions you can't feel. Let that thought deepen. Imagine carrying it to its limit. What if, at some level, the universe could exist without time altogether? What if what you call time is only a local property, something that emerges when certain conditions are met? There's a helpful analogy: temperature. A single molecule doesn't have a temperature. It has energy, motion, direction. Temperature is a word we use when many molecules move together, when there is a crowd of tiny motions to average over. It's a concept that appears only when enough pieces interact. You don't talk about the temperature of one atom in the same way you talk about the temperature of a cup of tea. Maybe time works something like that. Maybe it isn't fundamental. Maybe it's a description that only makes sense when matter and energy arrange themselves in particular ways, when there are enough events, enough changes, enough structure for before and after to mean something. There are theories in physics that treat time exactly in this emergent way. In some approaches to quantum gravity, the attempts to weave together the rules of quantum mechanics with Einstein's space-time, time disappears from the most basic equations entirely. What's left is a description of the universe in terms of relationships, not motion. The equations don't say, this event happens, then that event happens. They talk about how one configuration relates to another, how different parts of the universe fit together in a timeless pattern. The notions of before and after that you depend on to make sense of breakfast and bedtime simply aren't there at the foundational level. If those theories are even partly right, then time may be something like a shadow cast by space and matter. When the universe is dense and structured, full of galaxies and stars and people and clocks, the shadow looks clear and steady. You point to it and say, that's time. But if you could peel things back to their simplest, most fundamental state, no structures, no familiar objects, just the raw fabric, maybe the shadow would vanish. And with it, time. Space would still exist in that picture. It could still be stretched, curved, and shaped by whatever is in it. There could still be distances and angles, a geometry that defines what near and far mean, but without the ticking clock you experience from the inside. Without the sequence of moments your mind strings together, the universe would be timeless. At first, that sounds like a contradiction. How can space expand if there's no time for it to expand into? How can anything change in a timeless universe? But that question only feels necessary because of the way you're used to thinking about change as something that happens step by step from past to future. In a truly timeless universe, expansion wouldn't be a process unfolding. It would be part of the universe's structure. The universe wouldn't grow. It would simply be big, with that size built into its very nature. The growing you think you see would be your way of walking through that structure, tracing a path from one slice to another, and calling that path time. It's hard to picture, but not impossible. When you look at a map, you don't see a road lengthening as you trace it with your finger. The road was always that length. Your finger doesn't make it longer. It reveals more of it to you as you move. In the same way, space might not be stretching in time from the universe's point of view. It might simply be what it is, fully and completely, and time might be nothing more than the feeling of your journey across it. If this is even roughly true, it draws you closer to something remarkable. A universe where time is not the stage, but a perspective. Not a thing that exists on its own, but a way of looking at something deeper and more complete. When we talk about the universe, we almost always frame it in terms of beginnings. We imagine a moment when everything started, an instant when the first light flared, when time itself began to tick, when nothing became something. The Big Bang is the story we're told, and in many ways, it's the best story we have. The evidence for a hot, dense early universe is strong. But what if that story, true as far as it goes, is not the entire story? What if the universe didn't begin at all in the way our language suggests? It's a strange idea because your mind is built on sequences. You wake up, then you eat, then you move through your day. One thing follows another. It's natural, maybe unavoidable, to project that pattern onto everything, even the cosmos. If there is a now, your mind insists there must have been a before. The laws of physics don't always share that intuition. Many of them don't need a beginning. In some of the deepest theories we have, the universe doesn't start. It simply is. The Big Bang, in that view, wasn't the first moment of time. It was just one feature in a much larger, timeless structure. Time as you experience it might emerge only inside certain conditions, after the universe has cooled and expanded enough for structures to form, for clocks and chemistry and complex change to make sense. Before that, in the raw, unstructured state, there may have been no before and no after in the way we understand those words. This isn't just idle speculation tossed into the night. In quantum cosmology, the study of the universe using quantum principles, there are models where the universe is fundamentally timeless. All of space, all of energy, all of the moments you could ever point to are contained in a single unified whole. You and I perceive a beginning because we are trapped inside one thin slice of that whole. From our narrow perspective, the Big Bang looks like the start, like the moment everything came rushing into being. From outside that slice, if outside is even the right word, it might simply be one region on a much larger map. No more the beginning than any other point on a circle is its start. Even Einstein, later in his life, brushed against this kind of picture. He once imagined a static universe, one that did not require time to march forward in order to exist. His specific model was replaced when we discovered that the cosmos is indeed expanding, but the deeper idea that the universe might not need a true beginning never fully went away. Modern physics keeps circling back to it. Each time we peel back another layer of reality, time itself starts to fade from the most fundamental equations. The closer we look, the less necessary it seems. And if there was no true beginning, there may also be no final end. Heat death, the collapse of stars, the fading of galaxies into a thin, cold mist. These may still be real within the slice of reality we inhabit. From where we stand, suns will exhaust their fuel, structures will break down, and the night will grow colder. But in the larger structure, the one that contains every moment equally, nothing is ever truly erased. Every star that burns out still exists in its own region of the map. Every moment in your life remains anchored in its place. The universe isn't throwing them away. You are just walking past them, moving your attention from one fixed point to another. This way of seeing things changes the flavor of some very old questions. What happened before the universe might be a question that dissolves at the edges, not because there is no answer, but because before doesn't exist at the most fundamental level. It's like asking what lies north of the North Pole. The question sounds meaningful until you see the whole shape. If that's how reality is built, then maybe the universe doesn't need time to explain itself. Maybe time is only a way for creatures like us to navigate what was always there. In that case, the Big Bang wasn't a beginning. It was the point at which the part of the universe we can inhabit and observe became visible and meaningful to us. Thinking this way can feel unsettling at first, like the ground is shifting, but it also carries a strange calm. If there was no true beginning and there will be no absolute end, then the universe is not rushing toward anything and not fleeing from anything. It is simply there, complete in its totality, while we move through it and feel that movement as time. There is still a question hanging softly in the background. If the universe is timeless in this deep sense, how do we explain the way you feel time moving? Why do you remember yesterday, but not tomorrow? What gives time its direction, if not a cosmic clock ticking somewhere beyond the stars? If you've ever sat in a quiet room and really listened to a clock, you know how persuasive each little tick can be. Every click of the mechanism sounds small and certain, another tiny step away from what was and toward what will be. But in the world of the quantum, that certainty begins to dissolve. At the smallest scales of reality, time itself seems to lose its familiar voice. It doesn't tick. It doesn't march forward in neat steps. It becomes something far stranger, something that might not exist in the way you think at all. Particles at that scale don't move from point A to point B like tiny marbles rolling across a table. They exist in clouds of probability, spread out as if they're in many places at once until you look. Between those moments of looking, the equations that describe this quantum world don't need time the way you do. They don't say, first this happens, then this. They describe relationships, static, timeless connections between possible states. From that quiet, abstract vantage point, the universe doesn't so much unfold as simply exist, and what you feel as the flow of time may be your mind's way of tracing a path through possibilities, one gentle moment after another. One of the most striking examples of a timeless universe comes from an equation with a quiet, almost unassuming name, the Wheeler-DeWitt equation. It's one of the attempts to bring quantum mechanics and general relativity together, to write down a single rule that speaks for both the smallest scales and the shape of space-time itself. And tucked inside this equation is something startling. There is no time variable at all. None. No ticking parameter. No t sliding along a line. The Wheeler-DeWitt equation treats the universe as if every possible state already exists simultaneously, not lined up in a neat row, not queued like passengers waiting for a train, but present together in a single, timeless whole. What we call time, in this view, is just the way the universe looks from inside one particular way of reading. That whole structure, not a property the universe itself needs in order to be real. In that picture, the flow of time becomes less like a river and more like a story your mind tells as it moves. Imagine holding a thick book in your hands. Every page, every chapter, from the very first sentence to the very last, is already there. The story does not grow as you read it. The pages do not materialize out of nothing. They exist all at once, pressed together, quietly, complete. When you turn the pages, your place in the story shifts, characters age, events unfold, mysteries are revealed. From your perspective as a reader, something is happening. There is a before and an after, but the book itself does not change just because you are reading it. The only thing that moves is you. Quantum mechanics, especially in its most ambitious forms, suggests that at its foundation, the universe might be exactly like that book, a static whole, already complete, in which what you experience as the present is simply the page your awareness is resting on right now. When you move to the next page, the book hasn't changed. You have. This might sound like pure theory, a clever way of talking, but even experiments hint at this hidden timelessness. In quantum entanglement, two particles can be separated by vast distances, kilometers, light years, whole stretches of space, and still behave as if they are somehow one. When you measure one, the other responds instantly, as though distance and time have been quietly set aside. It's not that information is racing faster than light from one particle to the other, breaking every rule we know. It's that, in the quantum view, both particles are not really separate objects trading messages. They are part of a single system, described by one shared state. From that deeper standpoint, there is no before or after between them. They simply are, together, in a way that doesn't care about the gaps of space or the lapses of time we think ought to lie between them. This is one of the reasons some physicists argue that time isn't fundamental. It may emerge only when you zoom out, the way temperature emerges when countless molecules bump and swirl. At the level of a single molecule, temperature isn't a thing. There is only motion, only energy. Temperature appears when you step back far enough to talk about the behavior of many particles at once. In an echo of that, time at the quantum level may vanish, replaced by a kind of raw, unstructured reality in which there is no intrinsic before and after, only relationships inside a whole. You only feel the ticking clock when you stand far enough away, when you group countless events together into something your mind can call a sequence. It's almost unsettling to be told that something as intimate as time might not be woven into the bottom of reality. But the more we dig, the more time seems to slip through our fingers. Classical physics gave us time as a steady backdrop, a stage on which everything happened. Einstein showed us it could stretch and bend, running faster here, slower there. Now quantum mechanics whispers that at the very bottom it might not be there at all. What we experience as time could be no more than a reflection of how we, as observers, interact with an underlying timeless structure. Like the moving spot of light from a flashlight sweeping across a wall, the motion we see is in the beam, not in the wall itself. And yet, if time isn't there at the quantum level, why does it appear so convincingly in our everyday lives? Why does the universe around you look so beautifully ordered, one thing happening after another, with a past you can remember and a future you can only imagine, somewhere between the quantum world and the world you move through every day? Time seems to reappear, not as something the universe has in its deepest bones, but as something that emerges when enough particles, enough interactions, enough complexity gather together and give rise to a sense of sequence. It's not time that creates change. It might be change that creates time. If that's true, then time is nothing more than a tool your mind uses to make sense of a universe that doesn't actually need it. A way of organizing experiences, arranging them, giving them a gentle order. And if that's the case, then the universe can exist perfectly well without time. It already does, beneath everything you see, in the equations that do not mention clocks, in the entangled links that ignore distance. Following that thought leads to another strange corner. If time vanishes at the smallest scales, what happens to it in the strangest places in the universe? Places where gravity bends reality so fiercely that even the idea of before and after starts to fall apart. To see where time begins to break down completely, you don't only look at the tiniest particles, you also look at some of the largest, most extreme objects we know, black holes. These dark, silent giants don't just warp space, they stretch time until it is almost unrecognizable. Imagine falling toward a black hole. At first, from far away, someone watching you might just see you drift closer, like a speck drawn into a drain. But as you approach, your movement from their point of view begins to slow. Your gestures become sluggish, drawn out. The ticks of your clock, if they could see it, would grow farther apart. As you near the edge, the event horizon, the point of no return, you would appear to freeze. From the outside, time for you would come to a halt. You'd be trapped on the edge forever, suspended in a single moment that never seems to end. From your own perspective, though, nothing that dramatic would happen. You would keep falling, feeling your own weight and motion continue. You would cross the horizon without any special shiver or warning. You wouldn't feel time stop. Instead, it would be everyone else, far away in the wider universe, who would seem to race ahead without you. Their clocks would spin faster. Their ages would leap forward. Whole eras would pass, while, for you, only a short while slipped by. This is one of the paradoxes of black holes. They divide reality into two viewpoints, both equally valid, both completely different. Time isn't absolute. Its meaning bends until the word itself almost stops making sense. The same fall looks timelessly frozen from one angle and perfectly ordinary from another. And it gets stranger. Inside the event horizon, the very roles of space and time seem to trade places. Moving forward in time becomes as unavoidable as falling deeper toward the black hole's center. You cannot resist it. There is no turning around, no hovering, no staying where you are. In a sense, time inside a black hole is no longer something you experience as a smooth flow. It becomes a direction, a path you are compelled to follow. like sliding down a slope with no way back up. For physicists, this isn't just a curiosity pinned like a rare insect in a display case. It's a clue. Black holes take the flexible time of Einstein's relativity and push it to its very limit. If time can slow to nothing at a black hole's edge, if it can twist roles with space itself, then maybe it was never as fundamental as we imagined. Maybe black holes are showing us the skeleton of the universe, where the layers of experience peel away and something deeper, something that doesn't depend on time at all, stands revealed. Even the event horizon itself adds to this quiet mystery. It isn't a physical surface you could bump your hand against. It's a boundary drawn by the rules of space-time. Cross it, and no signal, no beam of light, no message can ever come back out to the rest of the cosmos. For someone far away, that boundary looks like the edge of time itself, a place where moments stack up and never move forward. If you could somehow stand safely and look at the horizon, you would see the last moment of anything that ever fell in, held in suspension, never quite finishing its fall. It would be like watching a raindrop hang forever just before it hits the ground. Beyond that horizon, we're in territory where our best ideas start to fray. General relativity says there is a singularity at the center, a point where density and curvature shoot off toward infinity and our equations lose their grip. Quantum physics suggests that such infinities might be a sign that we're using the wrong language, that there might be no singularity in the simple sense, only a different kind of region where space and time stop being meaningful concepts at all. Some scientists argue that whatever happens inside a black hole could be the key to understanding the universe itself. Because if you can explain why time breaks there, why it twists, stretches, and finally seems to disappear, you might understand why it appears anywhere else at all. You might see how a timeless foundation gives rise to the gentle, familiar flow you feel as your life. This is why black holes are more than just exotic monsters at the edges of galaxies. They're natural laboratories for the deepest questions we can ask. They show us what happens when time is pushed to the edge of existence, stretched until it nearly snaps. In their dense silence, they might be telling us that the universe doesn't need time to be what it is. But black holes are not the only places where time fades. Beyond their event horizons, in the fiery fractions of a second after the Big Bang, and in the quantum fabric beneath everything, the same pattern keeps appearing. Time is not fixed. It is not universal. In the most extreme conditions we can imagine, it might not exist at all. If that's true, we're left with a strange, delicate conclusion. Time might only be a convenient story, a useful approximation that applies where we are, at the scale we live in, under the gentle conditions we know. Step outside those conditions toward the edge of a black hole, or down into the foundation of the universe itself, and the story unravels. The question that lingers is what that means for us. If there are places in the universe where time doesn't exist, then maybe time isn't the rule. Maybe it's the exception. And if that's the case, we have to ask what reality looks like when you stop treating time as the thing that holds it together. If you could rewind the universe, not just back to the first stars or the first atoms, but all the way down to its earliest, most compressed state, you might expect to find time itself ticking faster and faster, counting down to some first instant of creation. You might imagine a moment where the cosmic clock begins, like a stopwatch being clicked. But what if, instead of speeding up, time simply stopped? What if, at the earliest stage before the universe as you know it began to expand and cool, there was no time at all? This is not just a dreamy thought. In some of the most advanced ideas in physics, the early universe wasn't just tiny and hot, it was timeless. The equations that describe the universe at its smallest, most compressed scale, before expansion becomes meaningful, don't include time as a variable. They describe something more like a static quantum state, a frozen hole with no before and no after, no motion, no change, only potential. It sounds strange, but it's not without precedent. In quantum mechanics, particles don't move in the way your everyday intuition suggests. They can exist in superpositions, in many possible states at once, like a chord rather than a single note, until something happens, an interaction, a measurement, that forces them into one definite outcome. Before that, talking about a clear path or a specific moment can be misleading. The particle is not here or there in time the way a small ball would be. It's smeared across possibilities. In a similar way, the young universe may have existed as a kind of cosmic superposition, a whole set of possible configurations held together in a timeless description. Only when it resolved into the expanding cosmos we inhabit did our familiar notion of time begin to make sense. From that point on, clocks could tick, events could line up, histories could be told. But beneath it all, in the language that tries to describe the universe at its most fundamental, there may be no ticking at all. The universe, at its very beginning, may have been something like a vast, quiet possibility, more like a held breath than an explosion. Not a tiny clock ticking faster and faster toward the first second, but a kind of timeless superposition containing every possible way the universe could be, all layered together at once. Nothing chosen yet. Nothing separated into this happened and that didn't. Just a swelling cloud of maybes. When cosmologists talk about this, they sometimes reach for phrases like quantum foam or the wave function of the universe. Those words can sound distant and technical, but what they really point toward is simple in spirit, a state where time doesn't apply. Not because time is paused, but because the ideas of before and after don't make sense there. There's nothing to compare, no earlier or later to mark off. It's as if the universe was holding its breath in a deep, timeless silence, not yet moving, not yet flowing, not yet dividing itself into the moments you and I now experience. All the structure you see today, stars, galaxies, planets, people, was still wrapped up in a single, undivided description. Only later, as the universe began to expand and cool, would something like time emerge. As energy spread out and matter formed patterns and clumps, a new kind of order began to take shape. Change became meaningful. Sequences became possible. Time, in the form we know it, crystallized out of that earlier, still state like frost, forming from invisible moisture on a window pane. Some researchers find it helpful to compare this to temperature. A single particle doesn't really have a temperature you can point to. It has energy, yes, motion, direction, but hot and cold are words that only make sense when you talk about an enormous collection of particles jostling and colliding. Temperature emerges when their collective behavior can be described with a single number. In the same way, the earliest universe may not have had time. There was no then because nothing had yet unfolded into a chain of events. Only when the universe grew, when it became structured enough for change to have a direction and for events to be compared, did time effectively switch on. It wasn't that someone flipped a cosmic light switch. It's that reality became rich enough for the idea of time to make sense at all. If that's the case, then asking what happened before the Big Bang might not be the right kind of question. If time itself didn't exist, there was no before for anything to happen in. What we casually call the beginning might simply be the point where time first became meaningful, where a timeless state gave way to the familiar ticking sequence that governs your days. It's an unsettling picture because it erases the simple idea of a starting line. The universe doesn't spring out of nothing in a single, sharp instant like a firework. Instead, it may emerge smoothly, naturally, from a state where nothing was moving and nothing needed to move because there was no time to measure motion in the first place. If this is even roughly true, it reshapes how we think about almost everything. It means time is not a fundamental feature of the universe, but a byproduct of its growth and structure. It didn't exist until there was something for it to measure, until the universe had patterns, changes, and events that could be ordered. And if time had to emerge, then it's not unreasonable to imagine that it could also fade away again. Under the right conditions, it might vanish, leaving behind the same kind of timeless state that may have existed at the start. Time would be like a phase of the universe, not its essence. This idea isn't just a distant abstraction. Physicists working on quantum gravity and cosmology actually use it to build models of the early universe that match what we see through our telescopes today. The ripples in the cosmic microwave background, the faint afterglow of the Big Bang, still whispering across the sky, may be the fingerprints of this transition from timelessness to time, like patterns left in sand as water pulls back. So, if the universe began in a state where time didn't exist, and if time only later emerged as a feature of the expanding cosmos, it leaves us with a quiet but extraordinary possibility. The universe doesn't need time in order to be real. Time is something we experience because of where and how we happen to exist, not because it is built into the deepest foundation of everything. If time can switch on, it's natural to ask whether it can also switch off. Could there be places, even now, where time is absent in the same way it may have been in the beginning? Places not at the edge of the universe, but right here, hidden in the deep structure of reality, regions where change doesn't happen, where the ticking of the cosmic clock goes silent. When you think about the future, you probably imagine something open and unwritten, still waiting to happen. The past feels fixed, the present feels immediate, and the future hasn't arrived yet. It seems obvious and comforting, one direction, one flow. But according to one of the strangest and most widely discussed ideas in physics, reality might not be arranged that way at all. This idea is called the block universe. In this view, the future isn't something that will happen later. It's something that already exists, not as a guess or a prediction, but as part of the structure of reality. Einstein's theory of relativity opened the door to this perspective. In relativity, there is no single universal now stretching across the entire universe. What counts as right this moment for you might lie in someone else's future or someone else's past, depending on how fast they're moving or how strong gravity is where they are. There's no cosmic line that cleanly divides past from future for everyone at once. That means all moments are equally real. They don't fade in and out of existence. They simply sit in different places in space-time, like different locations on a map. Your yesterday and your tomorrow are just coordinates in that four-dimensional landscape. Imagine, again, holding a book in your hands. Every page in that book exists at the same time. The page you're reading now feels uniquely alive because your eyes and attention are resting on it. But the other pages are not waiting to be written. They're already inked, pressed, and bound. You'll get to them eventually, but they don't spring into existence when you turn the page. They've been there all along. In the same way, the block universe suggests that every moment, yesterday, today, tomorrow, exists all at once, laid out in a four-dimensional structure. You are simply moving through it, one page at a time, with your mind acting as the reader. This view changes everything about how we talk and feel about time. The future stops being a blank space waiting to be filled in. It becomes as real as the past. You just haven't reached it yet. And if that sounds unsettling, it's worth remembering that this isn't an extra decoration added on top of physics. It is a natural consequence of relativity as we understand it. Nothing in Einstein's equations picks out a special now. The laws of nature treat all of time the same. In this framework, time doesn't really flow. There is no universal clock ticking forward, no river sweeping the universe along. Instead, what we call the passage of time is simply how our minds experience movement through this unchanging structure. We don't notice all the other moments because consciousness seems able to occupy only one slice at a time. The rest are hidden, not because they don't exist, but because we're not there. This idea even offers a gentle new way of thinking about memory. You remember the past not because it's gone, but because it's the part of the block you've already moved through. The future feels unknown, not because it doesn't exist, but because your awareness hasn't arrived at that part of the map. From outside the block, from a perspective no human being actually has, there would be no difference between past, present, and future. Every moment would sit there in the fabric of space-time, equally real, unmoving, and complete. Of course, this raises the questions that always seem to follow when we talk about fate and freedom. If the future already exists, does that mean everything is predetermined? Are your choices illusions? Some physicists and philosophers suggest that even if every moment is fixed within the block, the experience of choosing is still part of the structure. The act of deciding, the feeling of possibility, the way your thoughts tilt one way and not another, all of that is written into the block as well. The block doesn't erase the reality of your choices, it contains them. Your moments of doubt, your sudden bursts of courage, your quiet changes of heart, they're all features of that four-dimensional landscape, no less real than a sunrise or a falling star. This perspective can be unsettling, but it can also be strangely comforting. If every moment already exists, then nothing is ever truly lost. The happiest day of your life, the people you've loved, the quiet evenings you thought were gone forever, they are still there, woven into the structure of the universe. You've moved past them, but they remain. And if that is true for the past, then the same must be true for the future. Somewhere in the block, every step you will ever take is already part of the whole. You don't have to chase it down or worry about missing it. It's already folded into the structure, waiting for your awareness to arrive. Still, there is a deeper question hidden inside this idea. If time is just a dimension of the block, and if all moments exist at once, why do you move through them in one direction? Why don't you experience the future the way you experience the past? Why does time, even in a timeless universe, still feel like it has an arrow pointing forward? If the universe is a vast block of moments, each one already there, then why does your life feel like a journey instead of a picture? Why do you feel yourself changing, aging, learning, and living through time instead of simply existing in it. One possible answer is that you're not just living in one kind of time, you're living in two. The first is cosmic time, the time of physics. This is the time measured by atomic clocks, by pulsars ticking in distant galaxies, by the expansion of the cosmos itself. It's the time satellites rely on, the time GPS systems must correct for when they quietly adjust their signals, the time astronomers use to track galaxies drifting billions of light years away. Cosmic time is objective and impersonal, written into equations and measured with instruments. The second is biological time, the time you carry inside your body. You can feel it in the beating of your heart, in the rise and fall of your breath, in the rhythm of your sleep and waking. It lives in the gradual changes of your cells, in the way your hair grows, in the healing of a wound, in the subtle way your body knows when to be alert and when to be tired, even if you never look at a clock. Unlike cosmic time, biological time is deeply personal. It's tied to memory and perception and the physical processes that make you who you are. It is the time of this felt long and that went by too quickly. These two times don't always match. In cosmic time, you might be hurtling through space at incredible speeds as Earth orbits the sun and the sun orbits the galaxy, and you feel none of it. A billionth of a second difference in a GPS satellite's clock can matter for positioning, but you are oblivious to it. In biological time, a moment of fear can stretch into an eternity. A single second of falling feels much longer than it is. A joyful evening with someone you care about can vanish in what feels like a blink. An hour spent waiting in a sterile room can feel thick and endless. Your inner time is elastic, bending with emotion and attention, bound less to relativity's equations than to the way you experience life. Even more quietly fascinating is how cosmic time and biological time interact. Astronauts who live aboard the International Space Station orbit Earth hundreds of kilometers above the ground, moving quickly through weaker gravity. From the perspective of cosmic time, their clocks run just a tiny bit differently than ours. Over long periods, they age imperceptibly less than people who never leave the ground. They inhabit slightly different slices of space-time. Even as that happens, their biological clocks carry on in the only way they know how. Heartbeats, breaths, cycles of sleep and wakefulness, all continuing to tell their own story. Cosmic time may put them on a slightly different track, but from the inside, they simply feel like themselves, living days that begin and end. Wherever you are on Earth, in orbit, or simply lying awake in a quiet room, your body's time is always grounded in the same familiar rhythm. You sleep, you wake, you grow older, you remember. Your brain knits all of these changes into a continuous story, and that story is what you call your life. The story your brain keeps telling of me, here, now, moving through my life, gives you the deep, almost unshakable sense of heading forward in time. You feel as if you're riding a thread that runs from your first memories towards something still unwritten. From a larger perspective, though, the universe might not be moving at all. It may simply be there, complete, while you move within it. Biological time is what makes the arrow of time feel so real. This arrow doesn't come written into the basic equations of physics. The mathematics of relativity works just as beautifully if you run it backward as if you run it forward. The laws don't care which direction you choose. But your body does. Like everything else made of matter, it's tied to entropy, the slow, steady tendency of things to spread out, to mix, to become more disordered over time. Eggs crack but don't uncrack. A hot drink cools down and doesn't spontaneously heat itself back up. The universe, as a whole, drifts toward more ways of being messy than neat. You are built inside that one-way drift. Your cells copy themselves and slowly accumulate changes. Memories are recorded in one direction, etched into the structure of your brain. You remember the past but not the future, because the physical processes that store memory are themselves one way. That's why broken cups don't leap back together on the counter. It's why you grow older and not younger. Your biology is a one-way process, unfolding inside a universe that, at its deepest level, might be timeless. When you think of time this way, it becomes clearer why your sense of it is so strong. It isn't just the ticking of a clock on the wall. It's the sum of everything your body is doing, every chemical reaction, every heartbeat, every breath, every step your neurons take as they weave moments into memory. Without this biological layer, time might not feel like it's passing at all. You would simply be like everything else in a block universe, without noticing that you were on the move. But because you live in this dual existence with cosmic time on one side and biological time on the other, there's a gentle tension at the heart of your experience. It means that while the universe as a whole may be timeless, your personal life is built entirely from change. You inhabit the part of the picture that moves, even if the larger picture never does. That might be one reason time feels so precious. It isn't a fundamental feature of the universe. It's a feature of you. You carry it with you everywhere, and it quietly shapes the way you see everything else as something you could lose, something that can run out, something you can give and receive. There's another layer to this, one you live through every day without thinking about it. Because if your body can experience time differently from the universe, what happens in the one place where your sense of time naturally fades away almost completely? The place where minutes and hours blur and the ticking of the clock loses its grip. That place isn't out in deep space or at the edge of a black hole. It's much closer. It's the world you enter every single night when you sleep. Every night, without ceremony, you step into a world where time almost disappears. You close your eyes, and the familiar rhythm of seconds and minutes begins to soften. Hours pass, but you don't watch them go. You might dream, and in those dreams, entire stories unfold, journeys, conversations, strange scenes, stitched together with a kind of internal logic that feels right while it's happening. Yet when you wake, you can't say how long any of it lasted. A while, you might think. I don't know. This is the strange way your brain loosens its grip on time and sleep. Sleep is not only rest for your muscles and senses, it's a shift in how you experience reality. When you dream, your brain doesn't keep time the way it does when you're awake. The inner clocks that help anchor you to the present moment begin to drift. A dream can feel as if it lasts for days or flash by in what feels like seconds. There's no reliable inner measuring stick. Your mind simply doesn't care about the ticking of the clock in the same way. It isn't bound to cosmic time or even to biological time quite as tightly. It slips sideways into something else, something closer to timelessness. This isn't just a poetic way of talking about dreams. Neuroscientists who study sleep have found that the networks in your brain responsible for tracking duration and sequence, the circuits that help line events up in order, become quieter when you drift into deeper stages of sleep. Instead of focusing on what came first and how long did that last, your brain turns its attention to weaving images, emotions, and fragments of memory into something that feels continuous, like a story. But it isn't being measured against the world's schedule. That's why dream time feels so strange and elastic. You can live a whole lifetime in a dream, grow up, travel, meet people who never existed, and then wake to find that only a few minutes have ticked past on your bedside clock. In those hours, your brain isn't counting seconds. It's building a world where seconds hardly matter. In this sense, sleep is one of the closest experiences you have to a universe without time. You still exist. Your thoughts still move, but they move without the rigid frame of before and after, holding them in place. You rarely wake up in the middle of a dream and wonder what time it is. That question belongs to the waking world, where alarms and schedules and commitments ask for your attention again. This nightly escape hints at something quietly profound. If time can lose its hold on you so easily, if your brain can function in a state where time is almost irrelevant, then maybe time isn't as essential to consciousness as it feels. Maybe it's just one mode of perception, one way of organizing experience among others. It also helps explain why sleep feels so deeply restorative. For a few hours, you're not just resting your body, you're stepping outside the relentless push of tracked time. You're slipping into a state where there is no rush, no countdown, no constant awareness of minutes slipping away. You float, and then you return. When you wake, the return to time can feel abrupt, like rejoining a current that was always there, but that you had been drifting above. The light through the window, the numbers on your phone, the obligations waiting for you, they all come back at once. It's easy to forget that just moments ago, you were in a world where none of that mattered. It's worth noticing how similar this is, in spirit, to what physics suggests about time itself. At the quantum level, in the deepest description we know how to write, there is no obvious ticking clock. Time emerges only when you zoom out far enough, when you look at large patterns and many events. In a quiet echo, your mind seems to do something similar. In dreams, it stops tracking time at the scale you're used to. It drops to a lower level where time is not the main organizing principle. Then you wake, you glance at the clock, and without thinking, you step back into the steady rhythm of seconds and minutes, into the story of your life, marching onward. You rarely notice the transition. It happens every night and every morning, like breathing in and out of a world with time and a world nearly without it. Maybe this is another clue. If your mind can so easily exist without time for hours at a stretch, night after night, then perhaps time really isn't the unshakable foundation we imagine. Perhaps it's something you use, not something you are. While your dreams quietly loosen your grip on time, there's a very different, very physical way reality toys with your sense of a steady clock. If you've ever stood on a mountain and looked down at the valleys below, you've felt gravity's pull in the most ordinary way. Your feet press into the ground. Your body leans against the weight of the planet. It feels simple, familiar. What you might not realize is that gravity isn't just holding you in place. It's quietly changing the way time passes for you. Einstein's theory of general relativity revealed something extraordinary and still slightly unbelievable the first time you hear it. Gravity doesn't just bend space, it bends time. The stronger the gravity, the slower time moves. This isn't a trick of perception or a weakness in your senses. It's real and measurable. If you lived your entire life near the surface of a very massive planet, your clock would run more slowly than the clock of someone who spent their life far above you in weaker gravity. You wouldn't feel any difference. Your heart would still beat in the same familiar rhythm. Your days would still feel like the same length. But compared to someone far away from that gravitational field, you would age just a little more slowly. Time itself, for you, would have been gently stretched. We've tested this idea on Earth with highly precise atomic clocks. Scientists place one clock slightly higher than another on a shelf, on a tower, in an airplane, and let them run. When they compare them afterward, they can detect the difference in time between clocks separated by just a few feet of height. The clock closer to the ground, where Earth's gravity is slightly stronger, runs infinitesimally slower than the one higher up. The difference is tiny, but it's there, written into the fabric of space-time. Near massive objects like black holes, this effect becomes dramatic, almost theatrical. There, gravity bends space-time so severely that time slows almost to a stop compared to the rest of the universe. If you stood safely near the edge of a black hole, close enough to feel its pull but not so close that you fell in while someone else remained far away, they would watch you move in slow motion. Your gestures would stretch out. Your voice would deepen and slow. Minutes for you might become centuries for them. From their perspective, you would appear frozen on the brink, endlessly approaching but never quite crossing, while the rest of the universe races ahead. And yet, for you, inside your own frame of reference, nothing unusual would happen. Your seconds would pass normally. Your body's time, your biological lived time, would feel as steady as ever. This is one of the strangest things about time dilation and gravity. Every observer's experience is self-contained. No one ever feels time slowing down for themselves. You only see it when you step outside your own local clock and compare it to another. It takes two viewpoints to notice that time is not the same everywhere. All of this means there is no single master clock for the universe. There are only countless local times, each shaped by gravity, motion, and position. A clock on a satellite in orbit runs faster than one on Earth because it's farther from our planet's gravity, even while its speed tries to slow it down in another way. GPS systems must quietly correct for all of this, or their calculations would drift and fail. Every piece of technology that depends on precise timing is, in its own quiet way, a reminder that time is not absolute. If time can be stretched and squeezed like this, it becomes difficult to keep believing in it as an untouchable, fundamental essence. A universal, unchanging flow would not bend under gravity, but time does. It adapts to the shape of the universe, to the curves and folds of space-time itself. In some places, those curves push it nearly to zero. It's in those extremes near black holes, in the early universe, and deep inside the equations of physics that we begin to glimpse what might really be happening. Time isn't the foundation, it's a side effect. Gravity shows us this clearly. As space bends, time bends with it, like a shadow that changes shape because something deeper has shifted underneath. And if that's true, if the shape of reality defines time rather than the other way around, then your nightly dreams, your slow aging, your quiet days and racing moments are all part of a larger, softer truth. You are carrying your own time through a universe that may not need time at all to be complete. When the shape of reality bends enough, time itself almost disappears. It's a quiet realization, but once you let it in, it changes the way you see everything. Because if time depends on gravity, on how space-time is curved, then it's not hard to imagine a universe, or even hidden regions inside our own, where gravity's influence or its absence makes time meaningless. That thought leads naturally to an even stranger question. If gravity can slow time until it nearly stops, what would it mean to live outside of time altogether? Not just as a clever idea, but in the way physics seems to allow at the edges of what we understand. The moment you try to picture living outside time, your mind almost immediately runs into a wall. You're so used to measuring life in seconds, minutes, and years that it's nearly impossible to imagine an existence where none of those units apply. Your memories are arranged along a line. Your plans stretch ahead of you. To take that line away feels like taking away the ground itself. And yet, physics keeps nudging us toward a reality where time might not be fundamental at all. If that's true, there has to be a way, however faint, to glimpse what such a reality would mean. Start by stripping away everything you usually associate with time. No clocks on the wall, no sunrises or sunsets marking days, no aging faces, no growing trees, no before or after. It sounds like emptiness, but it isn't. What's left is still the universe. Stars would still exist. Matter and energy would still be there. The fabric of space would still have shape. What would be missing is change. Without time, nothing would move from one state to another. There would be no cause and effect, no sequence of events, just a complete and unmoving whole. Not frozen in time, but beyond the need for time altogether. This isn't just a poetic daydream. It's close to what many theories in physics describe at their most fundamental level. In some versions of quantum gravity, the attempts to unify quantum mechanics with general relativity, there is no time variable at the base of the equations. The universe is treated as a single, timeless object, with every possible state it can have existing together. In that view, time isn't something the universe possesses. It's something that appears only when you look at the universe from the inside, as an observer following one particular path. From the outside, there is no unfolding, no happening. If you could step back far enough, you wouldn't see events flowing. You would see everything at once, every moment that has ever been or ever will be coexisting like points on a vast, intricate map. There would be no need to move from one moment to the next, because every moment would already be there. The whole story would be written from beginning to end, though those words might not really apply anymore. From where you stand, this is almost impossible to imagine, because your experience of life depends entirely on change. You feel time because your body changes. You remember the past because your brain stores traces of what happened. You anticipate the future because your mind can project patterns forward. If those processes vanished, if there were no memory, no aging, no expectation, what's left wouldn't feel like life at all. It would be something entirely different, a state of pure existence without any sense of passage. And yet, in a small and gentle way, you already brush against this idea every day. When you sleep deeply and wake up with no memory of the night, hours have passed, but it doesn't feel like they did. It's as if you jumped from one point to another without crossing the space in between. For you, those hours didn't exist as experience. There was only one moment, then another. That isn't what living outside of time would truly be like, but it's a hint. It shows how easily your mind can skip over the experience of duration and simply be here and then there without feeling the movement between. It reminds you that your sense of time is tied to your awareness of change, not to some separate cosmic substance flowing through you. If time really emerges from change rather than the other way around, then living outside of it wouldn't mean floating in darkness or nothingness. It would mean existing in a state where everything simply is. No waiting, no moving forward, no sense of loss, because nothing can ever be lost if all moments exist forever. There would be no too late, no already gone. This is why some physicists and philosophers don't see this idea as frightening, but as strangely peaceful. If the universe at its deepest level is timeless, then everything that has ever happened and everything that ever will happen is woven into it permanently. Nothing vanishes. Nothing is erased. We only experience it one piece at a time, because that's the only way a mind like ours can cope. But if that's true, a new question rises quietly into view. If time isn't fundamental, and if reality might be timeless underneath, why do we experience time the way we do? Why do we live in this one-way flow instead of seeing everything at once? The answer might not be that time is a simple illusion, but that it's a kind of lens, a way of looking that turns a timeless universe into something habitable, something you can move through and make sense of. To feel what that means, imagine pushing the idea a little further. What if time stopped entirely, not just for you, but for the whole universe? What would you expect? You might picture everything freezing in place, planets halted in their orbits, waves locked mid-crest, birds arrested in mid-flight, every thought in every mind suspended, a great cosmic pause button pressed. But if time really did stop, there wouldn't be a moment for you to notice it. There wouldn't even be a you in any active sense. That's the paradox. When you take time away, change disappears with it. Motion, memory, cause and effect, they only make sense inside time. If time stopped, nothing would happen, not even the stopping. The universe wouldn't freeze in some dramatic tableau. It would simply be in a state with no before and no after. No story, just the whole story, all at once. This is one reason many physicists suspect that time isn't a fundamental feature of the universe. There doesn't seem to be a cosmic clock that can run down or suddenly halt. Time doesn't appear to exist independently at all. What we call time may only be the way we keep track of change and relationships. Take away the changes, and you don't just stop time, you remove the very need for the word. You can see a shadow of this idea in the mathematics of physics. The equations that describe the universe don't require a universal ticking clock to make sense. They describe relationships, how one thing depends on another, how matter and energy interact, how fields influence each other. When nothing in those relationships changes, time becomes irrelevant. It simply drops out of the story. Your own experience supports this in small, quiet ways. Think about moments when you've lost all sense of time, staring at the sky until your thoughts empty out, floating in water, drifting towards sleep, or listening so intently to music that everything else fades. Time didn't really stop, but your awareness of change became so faint that it almost felt like it had. In those moments, you weren't counting seconds. You were simply existing. Nothing seemed to move inside your attention, even though the world outside kept going. It's a tiny human echo of a larger truth. Without noticing change, time loses its grip on you. That's why, if time were to stop in the deepest sense, nothing would actually feel different. There would be no feeling at all. A timeless universe wouldn't be empty or dead. It would be complete. Everything would exist simultaneously, every event, every detail, but there would be no motion through it. No frames after frames, no story unfolding, just the whole, all at once. In some theories, especially in quantum gravity, this is exactly how the universe is described. Time does not appear explicitly in the basic equations. The universe is treated as a static object, an all-at-once structure. What we call the flow of time isn't something the universe is. It's something we experience because we're traveling inside it. We're moving from one region of that static whole to another, and our minds translate that movement into a narrative. If you could somehow remove that narrative, if you could step outside of it, you wouldn't see time slowing, stopping, or starting. You'd see that it was never running in the first place. You'd see a vast, quiet completeness. In that sense, asking what happens if time stops is a bit like asking what happens to a room when you turn off the light. The objects in the room don't vanish. The furniture doesn't cease to be. You have only lost one way of perceiving them. They're still there. You just don't see them as you did a moment ago. Seeing time this way isn't an ending. It's another shift in perspective. If nothing would change in a timeless universe, then time might not be the foundation we've always assumed it was. It might be a convenient way for us to move through something that never needed to move at all. From that point, one more idea comes into focus. One that many physicists and philosophers quietly meet around, even if they approach it from different directions. That the only thing we ever truly touch is the present. Not because the past is gone or the future isn't real, but because every moment is part of a single, eternal now. If you've ever sat very still and felt a moment stretch until it seemed to hold the whole world inside it, the hum of a room, the softness of your own breathing, the weight of your thoughts, that's a small brush with an idea people have circled for centuries. The idea sounds simple. The only thing that truly exists for you is now. From the perspective of physics, this is tied to relativity. There is no universal now that all observers share, no single slice of time that covers the entire universe. What you call the present depends on where you are and how you move. Two people in different places can disagree about what now even means, and both can be right in their own frames. That alone suggests that the flow of time is not absolute. It's a matter of perspective, shaped by position and motion. Philosophers have been saying something similar much longer, with different language. For them, the present isn't just a razor-thin boundary between past and future. It's the only place anything ever happens. You cannot live in the past. You cannot stand in the future. All you ever truly occupy is this continuous moment, endlessly renewing itself. Here, science and philosophy quietly meet. In some interpretations of modern physics, the universe is not really flowing from one moment to the next. Every event, every heartbeat, every star igniting, every word you'll ever speak is embedded in space-time all at once. From outside that structure, if such a vantage point existed, there would be no past and no future, only an all-encompassing is. From inside it, where you are, this deep, eternal now is felt as a sequence of moments, like beads on a string. You can't see the whole string. You can only hold one bead at a time. And that bead, this moment, right here, right now, is all you ever directly touch. From the outside, there may be only a single, silent, eternal structure. What you call now is simply the point in that structure where your awareness happens to be resting. That doesn't mean the past is gone, or that the future is some thin outline waiting to be filled in. It means they are both as real as this instant. You just can't stand in all of them at once. Your mind is a traveler, and the present is the narrow path it walks along, but the path itself is already there. You are not carving it out of nothing with each step. You're following a route that has always been part of the landscape. Strangely, this idea isn't bleak. It can feel deeply comforting. If every moment exists forever inside that structure, then nothing is ever truly lost. The laughter of a child echoing down a hallway, the warmth of a single soft afternoon, the way the stars looked on one perfectly clear night, all of it still exists, written into the universe as firmly as the laws that hold it together. You've simply moved past those places, the way you move past towns on a long train journey. They're still there, quietly, themselves, even after you can no longer see them out the window. And if the future is also part of this eternal whole, then it isn't rushing toward you like a wave you have to outrun. It's already waiting, folded into the same structure as your past. Every step you will ever take is already part of the pattern, not to trap you, but to hold you. This is one way of understanding the eternal now, not as a single thin second constantly slipping away, but as the entire universe seen all at once. Philosophers have reached for it through reflection. Physicists have brushed against it through equations. From opposite directions, they seem to meet in the same quiet place, the realization that time, as you feel it, is just one way of looking at something much bigger than any ticking clock. If the universe is already complete, if every moment exists inside this unbroken whole, then maybe you don't need to hold on to time so tightly. Maybe it's enough simply to rest in it, to exist in this tiny slice of infinity, knowing that nothing is ever truly erased and nothing finally ends. The story might be larger than you can see, but your page in it is safe. That leads to a gentle, almost circular question. If time isn't fundamental, and yet every moment exists, then what exactly is the universe made of? Is it a world without time at all? Or is it nothing but time, every instant, every change, every possibility, spread out like a great still ocean? These two ideas sound opposite, but they might be two sides of the same view. When physicists talk about the block universe, they describe time as laid out like space, a dimension that doesn't move, but simply is. From that perspective, there is no flow, no universal now, no single moment that deserves to be called the present more than any other. But that doesn't mean there is no time. It means the universe might be made entirely of moments, all resting together in one unbroken whole. If that's true, then time is not something that passes, it's something that exists. The future doesn't arrive any more than a distant mountain suddenly pops into being when you walk toward it. It was always there on the horizon, you just couldn't reach it yet. From inside your life, though, this doesn't feel like a static sculpture. You live inside time as if it were a river. You measure it, you worry about it, you feel it pressing gently or heavily around you. That feeling may be nothing more than consciousness traveling through the larger structure, one point of awareness sliding along a dimension that itself never changes. Even if the universe is timeless in its deepest description, time is still what you see from the inside. That's why the question, does the universe have time, or is it beyond time, refuses to settle. To say the universe has no time is true from one point of view. To say the universe is made of time, made of every moment that ever was or will be, is just as true from another. The difference isn't in the universe, it's in the vantage point. From one side, the whole is silent, complete, already there. From the other, it moves and breathes and unfolds. And both views, impossible as it seems, can be true at once. You don't have to pick one and throw the other away. You can live in time without being imprisoned by it. You can imagine the timeless whole without needing to step out of the present. You can let both pictures sit side by side in your mind, the physicist's map and the philosopher's meditation, each pointing toward a universe that is stranger, softer, and quieter than the mechanical ticking of any clock. After everything we've wandered through the slowing of time near gravity, the timeless hints in quantum theory, the block universe where every moment exists at once, it's tempting to think that fully understanding time would somehow change how you live inside it. But the truth might be simpler and kinder. You don't need to solve time. You only need to feel it. Because no matter how strange the underlying reality may be, no matter how many theories point to time as something emergent or illusory, this moment is still here. You are still breathing. Your heart is still beating. Somewhere outside your walls, the world is still unfolding in its own quiet way. You don't have to reach back into the past or stretch yourself into the future to find something real. It's already here, in the present, waiting for your attention. If time is a landscape, you don't need to see the entire map to walk the path beneath your feet. If every moment exists in the structure of reality, you don't need to cling to the ones that have passed or race toward the ones still ahead. They're already there, settled and safe, whether you worry about them or not. All you ever really have to do is take the step in front of you now. Seen this way, the science doesn't make time meaningless. It makes each second feel more precious, not less. If every moment is part of an eternal whole, then this one, the one you are in right now, is not going anywhere. It won't be erased when the clock changes. It will always be part of what the universe is. So you can let yourself breathe. Feel the weight of this instant without trying to stretch it, trap it, or slow it down. You don't have to fight time. You don't have to catch it or hold it. You can simply rest inside it, the way the universe has been quietly resting in every moment since long before you were here to notice. You don't have to understand time to be at peace with it. You only have to live in it one breath, one heartbeat, one soft present moment at a time. That's enough. Even if the universe doesn't need time, you do. Not because it's real, in the rigid way we once assumed, but because it gives you a gentle way to move through the infinite without being overwhelmed. It gives you a way to be here, now, while everything else, past and future alike, waits patiently in the background, as it always has, and as it always will.